In this video, I'll talk about three new concepts related to the motion of gas particles: mean free path, diffusion, and effusion. Let's imagine in air there are numerous oxygen and nitrogen molecules. They move around at several hundred meters per second, and they collide with each other constantly. Let's look at this picture here. Imagine this blue sphere is one of the air molecules. The red ones are other molecules. This blue sphere moves straight until it collides with this red sphere, and then changes its direction until it collides with the second red sphere. It keeps colliding with red spheres, and between two successive collisions, for example between these two, we have a straight free path. The so-called mean free path is the average distance a gas particle travels between two successive collisions. So let's look at this picture again. Between these two collisions, we have one segment. Between these two collisions, another segment. The third one, fourth, fifth, number 6, number 7, 8, 9, 10, 11. So we have a total of 11 segments between two successive collisions. All we need to do is to sum up the length of the 11 segments and then divide the sum by 11. We'll get the mean free path of this blue sphere. Now you can imagine if we have much larger molecules in size, it's more easily for collisions to happen, and then we have a shorter mean free path. If we have molecules that move faster, then the collisions are more frequent. We have smaller mean free path. Also, if we have more particles in the same container, and then the density of the gas particles is higher, which also results in shorter mean free path. Now let's look at diffusion. Diffusion is the net flow of gas particles from a high concentration area to a low concentration area. For gases, its pressure is proportional to the concentration. Let's look at this video of diffusion of ammonia and the diffusion of HCl. Ammonia, HCl.
Diffusion is the process whereby molecules of gas move to completely occupy a space, giving a uniform partial pressure. In this example, gaseous ammonia and hydrogen chloride diffuse through air from either end of a sealed tube. When the two gases meet, a precipitation reaction occurs, forming ammonium chloride. The mass of the hydrogen chloride molecules relative to those of ammonia is greater. Thus, hydrogen chloride molecules travel more slowly.
Finally, effusion. Gas particles can escape from a container via a tiny hole. This hole is small enough that only one particle can pass through at a time.
Effusion is the process of gaseous atoms flowing into a vacuum through a hole in a container. the rate of effusion of gas molecules at constant temperature and pressure is inversely proportional to the square root of the molecular weight of the gas.
Now you can tell the difference between diffusion and effusion. Diffusion occurs when there is a concentration gradient. Effusion occurs via a tiny hole that allows only one particle to pass at a time. Lighter molecules or atoms diffuse and effuse faster. This is because their diffusion or effusion rate is proportional to the speed of the gas particles, and the speed is inversely proportional to the square root of the mass. Therefore, the diffusion and effusion rate is proportional to the speed, which is proportional to 1 over the square root of the mass, which is proportional to 1 over the square root of the molar mass of the gas particles. This m, uppercase M, and this m, lowercase m, differ by a factor of Avogadro constant. Let's work on one example problem here. What's the ratio of diffusion rate of hydrogen and oxygen? Very simple, the diffusion rate is proportional to the square root of 1 over the molar mass. Therefore, this is for hydrogen, this is for oxygen. Compute the ratio, the result is 4. Qualitatively speaking, H2 is lighter and thus diffuse faster than oxygen. Similarly, H2 diffuses faster than O2. Now let's work on a practice problem. What's the ratio of effusion rates of helium and argon? The answer here is in font size 2.